Okay, and we are on our way. So the first thing that I want to do is do the homework assignment review. So basically, if you had a chance last time to at least watch the recorded video or you were part of the video itself, we basically implemented a International Space Station tracker app, and we use the map view to kind of show where it is at any point in time. And but what we wanted to do in the homework was do another API call and actually display when, based on time, the International Space Station would be over your house. So that might be a cool thing to do. So that's the homework assignment. So I want to jump in and kind of show you how I solved this. And first of all, let's go to yeah. So if you're able to see the web page here, so this web page is basically showing 3 different API calls that you can make. And they've got documentation over here on them. So like this one was the one we did last time. And this is where you got your current latitude and current longitude in this JSON payload for wherever it is at any point in time. And it's interesting, this current lat and long, when you actually call it, the lat and long do not come in as integer values or double values, binary values, but they're actually come in as strings. And that can cause some confusion because the next one I'm going to show you, it doesn't do that. It actually does it correctly. So over here, the second one, this ISS pastimes, if we go in here, we can click through it and we can see an overview of how this API works. So it describes everything about it, which is great. It has a nice overview and it tells you the various inputs that you have to give in your call. And then they give you an example HTTP request here, which is exactly, you know, what you want. And notice it's basically an HTTP request with a comma, or I'm sorry, a question mark, and that's where you put your parameters. So lat is lat here equals, and then whatever your real latitude is, you would put that in there. And then at LON or and LON is how you break up the parameters in like 4 different parameters. You would have a question mark to start, and then you would have an ampersand to separate each of the others. And so we have a longitude here. And then they try to explain to you exactly and show you what the payload is going to look like. So my suggestion with all of this is that you guys use Postman to, it's free and it runs on both Mac and Windows. And you can basically go up here and put the call in and hit send, and you can get a nice view of the actual payload that comes back at any point in time. So this is, I'm hitting the real API out on the web or out in the cloud, and then this is the data that's coming back. And so this is, so for example, when I look at this, it's saying here that there's going to be an array of these objects of rise, time, and duration. And then they don't tell you how many's here because it depends on how many you've requested or the default. What I like about Postman is I get the actual detail right here. So I see the actual call and here's the actual data. And this JSON is a little different from the one we did last week because it now, in this key value pair, the key is response and the value is actually an array. And we know it's an array because of this left bracket and right bracket. And then it is an array of dictionaries which have key value pairs. So there's a duration followed by a number, and then a rise time followed by a number. So if you read the documentation, this is actually a number of seconds since the epoch 1970, January 1st. And that's a classic Unix time. And so these are the times that it's giving us. And then what we'll do is we'll convert that into something readable so that we can understand what the real time is. So this is, you know, use Postman to hit these calls. Even though it's very nice that they did all this explanation here, I just find it's easier to use Postman and look at what actually comes back. So if we go into the app from last time and we run it, what you'll see is I've added basically this get ISS location still works, but I've added a second button here that says get overhead time. And when we click on that get overhead time, that's when we want to, and I'm going to just print it out basically down here in the log as a print, because I will have shown the concept of how you would do this. But you could actually have it go to a label on the display on your phone, which would be more reasonable, because if you're taking your phone around and you want to show somebody and get it, you'd want it to come up here. So what I've done is ahead of time, I've already mapped this button to the get overhead time tapped. And this is the button that will be called when you tap the button, or I'm sorry, this is the method that'll be called when you tap the button. And what we need to do is actually make the call. So first thing we want to do is we want to create some structs that represent what we see here in this payload. So we know that we have this response type here, which is an array of another struct, if you will, another key value pair. So what we can do, and I'm going to just step through this like this so that you guys can see it, but you don't have to watch me type everything based on the time we have. So the first thing I'm doing is I'm creating this struct that says overhead payload. And we want to make sure that it is conforming to decodable. That's decodable is allowing us to convert the JSON to a struct in Swift. And so without that, we're not going to be able to do that conversion easily. And then you'll see what I did here. I have a var duration, which is int. So that corresponds to this right here. Duration is the key, and this is the int. So that's the integer value. And then rise time corresponds to rise time here, exactly, character by character, which they have to do. There are ways to map it to different names, but that's beyond the scope of what we're doing today. So just make sure that these match. And then over here, you have this really what's a double. And it turns out that's the same thing as a time interval. And so that's what I put in here for the rise time is time interval. Now we want to actually, so now we've represented this, we want to go back a level and represent this whole thing. And what I did is basically did this, put this in here. So now what this is doing is it's taking the message, which is a string, and that is message right here is a string. And then the response is here, and it's an array of this overhead payload. And you'll notice that there's a third thing here, which is this request. It turns out in my code, I don't use any of this data, so I don't even have to put it in here. I can just leave it out, and it won't affect the decoding. It'll only decode what it finds. It won't error out or create nil if you haven't expressed the whole payload. You can just grab bits and pieces, which is what I'm doing here. So that's basically the structure that we needed to set up so that we can decode it. And then what we want to do is we want to get our URL. So let's go to here, and we're going to basically just take a variable and call it URL, and we create a URL by calling URL, the class. And in this case, we pick string. You can pick a bunch of different URL types. And then we're passing in the actual call that we want to do. And in my case, I was lazy and I just put in my current lat long here in Chicago. So that was, you just Googled it and away you go. And then one of the things I did here is I put this bang or exclamation point at the end. Does anybody want to tell me what that does?
It unwraps it.
It unwraps it. And is it, am I being safe when I'm doing this here?
Not really.
Why is that?
You need to use a guard because something might not be there, be in that information right there. I mean, it looks like it's an address, but there might not be any information there. So you probably need to use a guard or a nil coalesce, whatever they call those things. Is that the right answer?
Exactly.
Okay.
So exactly. So there's two philosophies here. First of all, you are exactly on the right track. That you would normally you'd use an if let or a guard against something to be sure that it's legal and it expands. However, in this case, since a user's not typing this in, we've already hard coded it here. So my position would be that, yeah, this is okay. This is the one case where I would say, if a student said, I just did the exclamation point there, the force unwrap, to me, it's okay and it's legal because I know that this is correct. And in the debug process, if it isn't correct, I know this is going to throw an exception and we'll fix it. So, that's kind of my take on that. So I think you're right on using the guards and the if lets, but in this particular case, I think it's okay to not do that. Okay, the next part of this is going to be a dispatch global dispatch q dot global spell. Does anybody remember what this does?
It's for when you want to call things in the background.
Exactly.
Asynchronously.
Yep, that's exactly right. So we remember the last session we talked about the fast lane and the slow lane. And what things belong in the fast lane? So the fast lane is your main thread, and that's the thing that's going to update the UI.
Okay.
So you want to, if you're not updating the UI, or you could still be in the fast lane and just do math. You can do all sorts of things. But as soon as you start going out to the internet, that's going to be slow, and that could take a while. And therefore, you don't want to do it on the main thread, or you don't want to be in the fast lane. So this basically puts you in the slow lane. And then what we want to do is we want to create a URL session, which is actually going to make the call. And let's close that off here. So URL session dot shared dot data task is the way we actually make this call, this URL request. And we haven't covered this, but does anybody know when you do URL session dot shared what that means? What that is? What is it returning? So basically, it's returning what we refer to as a singleton. And a singleton is something that, what this says is URL session shared means that object that you get back is always the same object everywhere in your code, no matter what you do. So you're always getting the same thing. The same thing is true here. Dispatch_queue.global is getting you the object that is global for the entire app, and it always gives you the same thing. It's like global data, basically. So this URL session.shared.data task is how we're going to make the call. And the other thing that we need to do with these data tasks is we need to add the resume at the end. So the way they've built this is their assumption is that you're going to want to build up a bunch of these and then fire them off later whenever you want. So they're queued up, but they're not actually going to happen. So we want it to happen immediately. So as soon as we create it, we can tack on the .resume at the end, and it will make the call. Just a fair warning here, this is really easy to forget to do, to put this at the end, and you'll keep running this code and you'll wonder why is it never making the HTTP request. And that's because you created the task, but you haven't said go do the task. So inside here now, we're going to basically, let me just grab this. And we can just talk through this. So for example, when the call returns, there will be data there will be a response code, which is like a 200 or a 500 or a 404 or whatever. And then if there is an error, we'll get some error data as well. In our case, though, we're just looking for I'm sorry, I'm just, there we go. There you go, Mia. Hopefully you weren't sitting in the waiting room too long. So, but I've got you in, there you go. So what's going on here is we get the data back. And so here we're saying if let the data. So what is this doing? Anybody?
It's checking to see if the call succeeded. If the URL call was, if the decoding was successful.
So right here, yeah, we haven't decoded yet. So all it's doing is making sure that
data's there.
Yeah, the data's there, exactly. So the next, you'd be correct on the next line, Joan. So right here, though, we're just getting the data payload. And if this errored out in any way, the data would be nil. And then this if let won't run at all, you know, or this inside here will not run. So now the next statement was, again, from what we did last time. So this is the same thing, except we're decoding off a different type. And we're doing a try here. And the try means that the way they've done this JSON decoder.decode is that it's, it wants to give you an optional thing back that may or may not succeed. And it also will throw an exception or throw a catch block if there is an error. Now, when we did this, we didn't put a catch block in here. So I know one of you that was working on the homework, you know, you were getting nil back because you had an error up here in how you set this up, but it wasn't telling you why. And the reason it's not telling you why is because we're not catching the error case here. So try catch blocks, that's a whole nother PD for another day. But basically, in this case, what you just have to sort of live with is if you do this wrong when you're coding it, you'll know it's wrong because payload's going to be nil. But if payload's not nil, you know that the decode worked well. And then here on line 34, we do a dispatch main async. So anybody want to throw in their hat on what we're doing there?
Is it dispatching to the main, to the fast lane? Is
That's
that what?
right. You're exactly right. You're off to the fast lane now. And
why?
Why?
Yeah, because you said I'm sorry. I just thought you kept all your internet stuff in the background. Sorry, please go ahead. I'm sorry.
Yeah, no, the great question. So the deal here is that this guy right here, when this runs, this shared data task, until it returns, until it gets in here, that's the thing that can take a long time. And that's why you want it in the slow lane. You don't want to interrupt the fast lane. But now that we're in here, line 32, 33, I mean, we could get back in the fast lane as soon as like right here, literally. You could go back to the fast lane. Because this decoding is all done locally right in the phone, and so it's going to be very fast. I typically decode before that. Each developer has a different way of when they want to do it. But I know I'm getting ready to put something in the UI at this point. Now, again, I'm doing a print to the console, but you might be probably setting a label, in which case you want to get back in the fast lane before you do that. If you try to set the UI in the slow lane, you're going to see weird things. It's not going to update. Then all of a sudden it's going to update out of the blue, and it's going to be very janky. And as soon as you see that, you'll typically know, okay, you're in the background, you're in a background thread, and you're updating the UI, and that will cause it to act funny. So here we are, we're getting back onto the main thread, and then we're saying if this payload actually did convert, and we've got the data, then what I do is I say, well, okay, if I got the data, I'm going to assume, again, that their response here is always an array of one or more of these. And I'm saying that I believe that they will never vary from that, in which case I could argue that, again, I'm taking the first element of the array and I'm just force expanding it so that I get the value. But this is probably a case where, because I'm going to an API, I might not always get that. So for the individual that suggested that we should be using guards or if-lets,
That's me.
You definitely should do that here, okay? So this is where, in a code review, if I was code reviewing with you guys, you would be throwing tomatoes at me and say, no, 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 you should be, that's not good coding practice here. So in my case, though, I've now got this variable called first pass, and that basically is going to be a struct that is just these two elements right here. And so what I do is there's a function, there's basically a whole package that works with dates called nsDate, and you can initialize it. And then one of them is time interval since 1970, because that's what these are. And I put the first pass dot rise time in there, and that's how I get, and then I print that, and that's how I get a pretty date from that. You can do, once you get the date in this form, like Joan, you were asking how to make this look good. Once you get that, there's a bunch of different functions that you can do on that to sort of bring out the date in the format that you want. So we'll go ahead and run this. And if I say get overhead time, you'll see down here, it did print a value. So we say the 28th at 2200 UTC time is when the ISS will be over Chicago, straight up above. Would the formatting go into a function? Yes, it will. It'll be a function. It'll be a function that you will apply to nsDate, and it will then return a formatted string. Yep. Okay, so that was the homework, and not the most trivial of homeworks to do. One other thing that was discovered that I did not cover in the previous class was that this InfoPlist, which sits in your every one of your projects, this is where you have to set up certain keys and certain things so that iOS knows that you've done everything the right way. And one of the things they don't like in the phone is for you to make requests like this, where it's HTTP with no S at the end. So basically what we're doing is we're making insecure HTTP requests. And that means that if somebody were sitting on the wire or in our Wi-Fi or whatever, they could just see it. It would just be completely clear to them in Wireshark or whatever, the data that's going back and forth. Now, we don't care in this case, and I don't even know if this API supports HTTPS. But what you can do is here you can say, allow arbitrary loads in this app transport security setting, which you will not see in this list initially. You have to go add it. So again, if you Googled this, you would find that this is documented relatively well, but what can be confusing is that this InfoPlist is not the only keys you can do. You can keep adding more and more and more keys into here, and that's how you would add that in. And once you do that, you'll be allowed to make the call. Okay, so let's jump into, that was the review. That was a little longer than I had hoped, but I think it was good that we got through that. So in this next section, notifications aren't that complicated, so I think we're still going to be fine on time. What I want to do is sort of talk about what are notifications, why are they important? There are various things that you're going to do with notifications. One of them is subscribe to it. So you're basically saying, hey, I want to know if something happens. Then there's also the sending of notifications. So how are notifications sent out to all the subscribers? And then there's, of course, responding to the notification. How do you respond to it? And so we'll jump into Xcode then once we just kind of look at the concepts on that. So one of the things we dealt with early on was delegation. And one of the ways that delegation works is you have a delegate over here, and then you have some object over here that is going to use the delegate. And so what happens is the delegate signs up as a delegate at some point in time before it's actually called. And it says, hey, I'm going to conform to whatever protocol you're telling me I need to conform to, so I'm good to go. And then going back, this object here can call the delegate and basically tell it information that it wants when it's appropriate. So the thing about this, though, is this is a one-to-one mapping. So you can think of this like it's subscribing, and then you can think of it like it's sending a notification, and it's doing that, but this only works on a one-to-one basis. And that means that if this object wanted to notify a bunch of different objects about a certain event, delegation is not going to work. So the thing to keep in mind with delegation is one-to-one. So here's an example of notifications. In notifications, for example, we have 3 observers here, and we have this notification center. The notification center is exactly how you type it out, and it's provided by iOS. So it's the thing that's going to manage all of these subscriptions and notifications. And what happens is each one of these observers will subscribe via the notification center. So it will talk to the notification center and subscribe, and it'll subscribe based on a name. So we'll have some name that we're going to give the notification. That can be completely arbitrary. It can be whatever you want it to be. And that's what's then used going forward with this. Then when we want to send a notification out, there's a sender somewhere. So somebody is wanting to send out this information. So what it will do is it will notify the notification center that it wants to send out a notification. And then the notification center will actually call each one of these subscribers at the same time, virtually the same time. So they'll all get the notice. And you can have 1 subscriber, 10 subscribers, 100 subscribers. It doesn't, I mean, there are limits to memory and so forth, but ultimately the notification center is going to notify all the subscribers that have said they wanted to know about that particular notification. And this is a one-to-many. So you have one person posting the notification and saying that we want this to happen, and then the notification center goes out to all of them. Now, the other thing to keep in mind is all of these, remember, everything on the iPhone is, anything that's executing is either going to be in the fast lane or the slow lane. And we have multiple slow lanes. We only have one fast lane, one thread one. And all the other threads, when you're in the debugger, are background threads. And the thing to keep in mind here is when the sender posts something to the notification center, if they're on the main thread, then all of these subscribers will get activated on the main thread. If this posts on a background thread, then all of these subscribers will get activated on the background thread. Okay. So subscribing to a notification, there are 2 methods of doing this. One is using a selector, and another is using a BlockCallback. The selector is the old method of doing it. It typically is still used a lot. It's really a throwback to Objective-C, and Swift kind of mapped to it directly. But we now have block callbacks that are very cool. You can do this in JavaScript, you can do this in Python, and you can do it in Swift. And I'm going to show you the 2 different ways to do this and why I prefer the block callback as well. So if we look at the selector, this is the code. It's basically 2 steps when you're going to subscribe to a notification. The first thing you want to do is you're declaring a function, and you're going to give it whatever name you want, and it's going to have this signature. It's going to have this notification, and then you're going to do whatever you want to do based on receiving the notification. So this function out of the blue is just going to get called for you when a notification happens, and it's actually going to pass the notification along. This @objc in the front of it is what we need to do to make it Swift understand that it's really a selector. And again, this is just syntactic information that you have to know to get it to compile and work. I'm not going to go into any more detail on that. That's just basically, you just have to add Objective-C there. And by the way, I think Xcode will warn you if you leave it out. So the second part of this is actually then adding the observer into the notification center, saying, hey, I'm here. So what you typically will do is you'll create a subscription name. And in this case, the name is com.cecse.mynotification. So does anybody know what I'm really doing here when I do com.this dot something else? I mean, why would I do that as a name?
It looks like this.
Package name?
I'm sorry. You both spoke at the same time.
I'll shut up. Go ahead.
Is it like a package name, like when you set up an app?
Yeah, exactly. And it's basically sort of reverse notation. You know, normally you would say, you know, foo.com, you know, and .com would be at the end. So the pattern here is to really reverse it. And the reason that you want to do this is because, remember, notification center.default is a singleton, and Apple and iOS is going, and in your app is going to use notifications behind the scenes, and you'll never know they're happening, but they have names. And so this ensures that you won't by accident pick the same name. They were not going to do com.cecse. But they might have had my notification. Unlikely, but so you can put whatever you want here, but this is good form. You see this and you go, oh, okay, this person knows what they're doing, because they wrote it in kind of this reverse notation. So that's just creating the subscription name. And then in here we say notification center.default, add observer. So the observer is self. That's me. This is going to be in a view controller. So that's the object that's going to be the observer. And then here we say selector is what do we want to call when the notification triggers. So when we get the notification, we're saying call this function up here, did receive notification. And by the way, we put that whole thing in parentheses with #selector. Again, this is all legacy from Objective-C, and it's just the way Swift does it. And then your subscription name that you have here is here. And then we won't worry about objects in this case, but I will just let you know that in notifications, not only are you getting a notification, you can get a payload of data as well. And so these objects can be very useful. So essentially, you just have your first part, which is creating this, the function, and the second part, which is where you add the observer, and then you need to reference that function up here, as a selector. So now let's look at the block callback. So the block callback is only one step. And the only difference is that the syntax can look a little weird with block callbacks if you're not used to them, but once you start using them a lot, and you can in a lot of cases, it'll become very natural to you. And again, this is something like if I think about app dev with Swift for students, you know, you have some students that may really excel and really want to move on to you know, more advanced areas of doing things. This is where they should go as one thing to try out, is go to the callback. So what happens here, we still do the same thing with subscription name, but then we have notification center default, add observer. Now the order here is different, but suffice it to say it's basically doing the same thing. They have for name, so that's your subscription name. That's what you're asking to observe for any notices to this. The object is nil. And in this case, the queue, you can specify the queue that these come off of rather than the default. We're just leaving it default, so we're saying nil. And then here's the callback right here. So literally you do this bracket, notification is like a parameter getting passed in, and then here's your code right here. So any idea why you think I like this over the other one? Other method?
Less code.
Less code, for sure. And when we did it before, sorry, let's go back to this guy. So in this one, what I don't like is this function and what it does is completely separated from where I'm adding the observer. This could be in a different file. This could be, you know, 400 lines away somewhere. And you really are creating a disjoint view of conceptually what you want to have happen. You've got, okay, I'm adding an observer here, and now I got to go somewhere else to find out what it does. And in the block callback, it's always going to be right here in line. So you're going to add the observer, and then you're literally going to put your function right there. So the nice thing about this is that it's all in one place, and you can, you know, it just doesn't create, it's less code, and it also doesn't displace the actual function to someplace else in your code. So now we've subscribed, how do we post a notification? So posting is super simple. You're literally going to do, you're literally going to call the notification center again, except now you're going to say .post. So you're going to post the message, and then you're going to give it that subscription name again. And we didn't pass any objects, so we put nil there. And literally, as soon as you do this, and you call that post, all those subscribers are going to get called at the same time. So with that, let's go jump into Xcode and see this in action. So what we're going to do is go to this other project. And basically what I'm going to do when this one runs is basically all I have is a button here. And when I click on this button down here in the log, I want to see some messages that say that these notifications have fired. So what we'll do is come up here. So the first thing that we want to do is we want to declare a subscription name. And by the way, I'm putting it here, but the likelihood is that you might want to declare your own class with a bunch of constants in it, and you might put all your subscription names there. I would actually promote that. I think that's good design. It keeps all of those things in one place, and you don't have these, and then you just reference it rather than doing it the way I'm doing it here. But given this small example and we don't have all that, I'm just putting the let right here in the view controller. And then what we want to do is add, let's do this guy. So when the view loads, that's when we want to add our observers. So what I'm doing here is I'm adding an observer, and I'm saying the selector, like we did in the example, and then did receive notification. And we're getting an error because we haven't defined this function yet. So if I come back here, we define that function. So all this function did was exactly what we saw on the slide. It says did receive notification. It's passed a notification, and it's going to print got a notification through a selector, and the selector now sees it, and we don't have any error. So this should work, but we have to actually post something for it to get triggered. So we do a view did load. We actually do the add observer, and when you tap the button, we want to post something. So I'm going to go down here and grab the post. And all I'm doing here is the same thing as we had in the slide, the default.post, the name, the subscription name, which is up here. And as long as those names match, I should at least see a print to the console. So let's try this. So if I run this again and I click button, there it says got a notification through a selector. So every time I hit the button, it does that. But we could have done that with delegation because this is just one-to-one. This isn't as interesting. So what if we added another listener? So we could do this by literally just copying this. And I could put 3 of these in here. And now I have 3 listeners. So now when I run this, what do we think will happen?
3 got a notification messages.
How many would we get?
I want to say 3. Is this a trick question?
Nope, 3 is correct. So notice every time I click the button, 3 pop out, right? Because we have three observers. It doesn't matter that each observer is calling the same function. Every time you add the observer, it's going to create a new observer object, and now it's going to notify that object that that post actually happened. So the other one I want to add in here is the doing the block callback. So if we go here and we do this guy right here. So now we've added another observer with the same subscription name, and notice my print statement's right here. Isn't that nice? I don't have to look up here and find this other function and reference it down here. It's all in line, it's all done in one spot. So now when I run this, how many times should I see, well, let's say from callback, how many times should this print statement run? How many observers do we have once all of these run? I just gave the answer away.
4.
4 observers. 3 of them are going to call this guy because that's what we coded right here. This one, the 4th one, or the first one, because this is the first in the order, is not going to call this because it's using the block callback, and it actually has the code right here. So this should only run once when we hit the button, while the others will still run 3 times. So we do this, and we do a button, and sure enough, we got 1 got a notification from callback, and then we got 3 got a notification through a selector, and that's basically it. You know, that's notifications. So they're really, the use for this is a lot of times you may get some data, let's say from the internet, or the user enters some data, and you have various objects all over your code that need to know that this data has changed. That's where you want to use this. That's where you want to add an observer and then do whatever you need to do when that data has changed. And you'll know that because that when that data was entered, you're going to do a post. So once that data changes, you do a post, you let everybody that's interested get notified of it. So it's really quite powerful.
Can I ask a question?
Absolutely.
When would object never be nil? When would object not be nil?
So object would not be nil if you're sending and receiving real objects of data. So right now, all we're doing is saying that we're posting that there is a notification, but we're not passing any data. So you can actually pass data, and this guy can receive data based on that and then react to it. So you can do more than just say, oh, I'm going to send you, this subscription name got triggered. You can actually give it the data that you want to provide with it if you want.
Is this similar to like how React works with this, the state change and all that stuff?
It's all intertwined, yes.
Okay. All right.
I'm not a React guy, I'm a Vue guy, but there's this concept of how objects communicate with each other is a rat hole that there's a bunch of different ways to do this. For example, you'll have people, if you look up singletons, you'll find out that a lot of people write in Medium and other things, they say, you should never use singletons. And I'm like, well, there's singletons all over the place in iOS. And there are times when it's good reason to have a singleton. The problem with singletons is it's global data. And we don't know if you cover this in the boot camp, but global data is typically considered bad because it creates it connects all of the different pieces of code, all get intertwined based on this global data. And then when you change your data in some way, it's very hard to figure out why things don't work. Whereas if you are very selective about what data is actually sent from one object to another, you're confining the problem down to something more simple.
That makes sense. Thank you. Thank you.
Yep. So I would encourage you to pass data here and not go to some other singleton or global data and say, hey, what happened? You know, you would want to do it there. So we did the code. So just a quick one in review. What is the difference between delegation and notifications?
One-to-one or one-to-many?
Exactly. That is exactly right. How many subscribers can you have to a notification? So there's no upper limit.
Oh, okay.
Other than the fact that, you know, it's like if you were to say, it's every time you add a subscriber, you're going to use memory, and memory's not infinite. So you definitely don't want to abuse it. It's definitely, if you have 1,000 subscribers on a notification center, I'm going to want to look at your code and figure out why. Because just keep in mind, when the notification goes off, all of those things want to run at the same time. So although there's no limit, just good programming practice would be only do as many subscribers as you absolutely need.
So Kevin, would this be a situation where you would want to have a backend for your app? Like, could you even do this if you don't have a backend?
You can do this if you don't, like when you say backend, like you mean calling the cloud, like a cloud service?
Yeah, calling the cloud, or having your app like kind of running in the cloud, or people are hitting, you know, some kind of a database or some kind of some kind of a cloud-based component of the app that's kind of running.
Yeah, so I mean, from the app's perspective, you're going to make a call. It's rare that there's a whole different protocol where you can tie in through TCP/IP and not use HTTP and literally get notified out of the blue of a database change, as an example. So that's not using HTTP requests, but it's a totally valid way to connect to the cloud. So you have a continuous connection there, and your app, when it gets a TCP/IP notice that, hey, the database changed in the cloud, you literally, a notification is thrown and you have a bunch of listeners listening for that. Now you can go do those things. So that's done quite a bit. And like Google's Firebase is a perfect example where you, under the hood, you don't have to worry about it. But when you use Firestore as your storage in the cloud, it literally, your app will just start reacting every time somebody changes something in the cloud. And it'll definitely use notifications for that.
Okay, thanks.
Yeah. So yeah, Mark, it's totally advanced. The goal of the program is not to, you know, the goal is not to get you guys to a point where I'm losing you, but I'm also trying to stretch a little bit so that you're, you know, once you kind of get this stuff, then going back to some of the stuff that you have to teach should be like no brainer at that point, you know. So third one, which thread does a subscriber get notified on?
So like a secondary thread, like not the main thread?
Okay, so if I'm notified on a secondary thread or a slow lane, what does that say about the poster that posted it?
That they were on a slow lane also.
Exactly, exactly.
Well, basically, then the subscriber would get notified on whatever the notifier is on.
That's correct. That's right. So if you don't want that, there are ways, if you just look in the docs, for saying that I want my notification to be on a particular thread. Or let's say the notifier is, you have no control over the notifier. It's a library that you loaded or whatever, and it's on the main thread. You get notified of it, but you don't want to work with that data on the main thread. You guys already know how to do that, right? You do dispatch queue async right after you get notified. And even though you were called on the main thread, you're pushed off to a secondary thread where you can do whatever you need to do. So, but just keep in mind, if you don't do any of that and you just leave it default, if it's on a secondary thread, you're going to get called on a secondary thread. If you're in the fast lane on the main thread, you'll get called on the main thread. Okay, we have about 4 minutes left. Any questions before we look at the homework assignment?
One question. So the subscriber gets called on the main thread, not the background thread.
I'm sorry, say again?
So the subscriber gets notified on the main thread, not the background thread.
So the subscriber will get called on the main thread if the poster who posted the message was on the main thread at the time.
Okay, all right. That's what I want to clear up. Thank you. That's all I had. Thank you.
Yep. Okay, so with that, homework assignment is as follows. Basically, I just want you to create a simple app that has a single view controller, and it'll contain 3 labels and a button. Initially, the labels should be blank. When you tap the button, update each of the labels with different text of your choosing. So whatever you want to do. But to do this, you must use notification and subscriptions. You can't do it any other way. And feel free to, again, this is sort of really showing that you understand the mechanism. But if you want to do something fancier, feel free. You know, sometimes I'm not the most creative guy, but I understand the concept. So this is why I use UX and UI people for making apps look good. But yeah, this is the assignment, and I think you'll have a pretty good feel for able to knock this out. Marvin, I'm glad you think this is cool. I think it's cool too. All right, well, if that's it, we're 2 minutes, 30 seconds to go. So I can answer any more questions or take requests or.
Can you, one question, I'm sorry. Can you explain one more time what a singleton is? If you can just keep it short. I don't want to take up no time.
Yeah, no, that's okay. So let's look at it this way. If we had the class called cat, which we had when we talked about inheritance, and I created 4 cats, all I would do is keep reinstantiating cat. I instantiate cat, I instantiate. Every time I do that, I'm going to get a different cat. So they are not the same. So if I called one cat, you know, gave it a name and then another one a different name, they would be different. A singleton is where I keep creating cat and I keep getting the same cat back. I keep getting the same thing over and over and over. And singletons play an important role in iOS and so forth. But for example, when we do core location services, it uses a singleton. When we do NS user default for storing data, it's a singleton. The dispatch queue manager is a singleton. Our notification center is a singleton. There's only one notification center in your app. There's not 10. There's only one. And that's, so hopefully that helps a little bit.
Yeah, it does. Thank you so much. Thank you.
Yep.
So Marvin, I really appreciate that question because you're making me think too about the constants, but I'm trying to think in my mind the difference between a singleton and a constant.
So good, yeah, really good question. So constants, the way I think of constants is constants don't change. So once you say pi equals 3.1415927, it's always going to be that way. You would have it as a let, which is a constant, and it never changes. A singleton, they change. They're just the same thing. So at one point in time, you had 3 observers. Now, the next point in time, you have 8 observers. And now somebody just posted something. They're all interacting with the same thing. It's like your car. You only have one car that say, you know, where the keys go with that car. And so you can get in the car and drive, or you can wash it, or you can stop, or you can fill up the gas. Any of those, that's changing the car in some form or fashion, but it's still the same car.
I get it. So you really can't have instances of a singleton. It's just like the one.
You can have instances and, oh, sorry. You can have instances and it's called one instance. One instance only. So once you create the singleton, then you've got it. So anybody else who creates the singleton, they think they're creating it. They're not creating it. They're just getting the one you created.
Okay.
Okay, this is great.
Thank you. Thank you.
Cool. All right. Thank you, everyone. And go for the homework.
Cool. See you. Thank you. Bye.
Take care.
Kevin, bye.
Thanks,
Bye.
Kevin.
Bye. Bye.
Bye, Mia.
Bye.
Bye, Marvin.
Bye. See ya.
Bye.